Okay, hi there. This is again the University of St. LaSalle College of Arts and Sciences Mathematics Department, and this is our video solution for our problem number 2, posted on our Facebook page with difficulty of 1 star. Okay, so here it is. Solve for k for this given equation over here. Okay, so this is an example of an equation with radicals, as you can see here. Remember radicals or roots as the opposite operation of exponentiation. That is, they undo each other. For example, 2 squared is 4 and the square root of 4 is 2. Well, technically, the square root of 4 is 2 and negative 2 because negative 2 squared is also 4. Okay, so it is quite mentioning that some people got this question right and who wrote or showed their answers with solutions in the comments on our Facebook page. Shane and Glenn, if I can remember correctly, thank you so much. That is really great, and hopefully more and more will participate in this activity of ours. Okay, so let's get started. Here's our problem again. Okay, with the steps now. So we are asked to get the value of k, and notice k lies on the exponent of these terms over here inside the radical signs. So we need to use our algebra skills, particularly our exponential equations, to solve this one. Okay, notice the indices, okay, which are the index here. So indices of our two radicals are the same. So we can combine these terms inside the radical signs, we call them the radicands, okay, and put them under the same roof. Okay, that is under one radical sign with the index 3. So we'll have it like this. Okay, so they're all under the same roof with the index 3. And then this term here, just put it here. Then this term here, put it here. There's a imaginary multiplication sign in between them. Okay, now we can get rid of this cube root of 3 here, okay, on the left hand side, okay, of the equation by exponentiating both terms by 3. That is, raising both the left hand side and the right hand side of the equation by 3. And we do that simply to clear out this radical sign over here. Okay, so if we clear this out, so we're going to imagine raising this by 3. If we do that, we need to raise this also by 3. So we have it here. Okay, so now we're cleared with the radical sign, so we'll simply simplify things here on the left hand side. Okay, since they have the same variable, x, okay, we can combine them. It's easy in the coefficients because, well, we just simply multiply the coefficients. 5 times 25 is going to give us 125. Just be careful with exponents. Okay, in this scenario here, the exponents are not the same. In this scenario, we're going to use the product law of exponents, where if you'll multiply terms with the same variable, you'll add up the exponents, okay, sum them up. Okay, so here we have k plus 1 and k. So if we're going to add them, this will give us k plus 1 plus k. Again, k plus 1 plus k, k plus k. We know that as adding the coefficients is 2k. So we'll have 125 as our coefficient, x raised to 2k plus 1. Anyways, here on the right hand side, we raise the former term, 5x to the 7th, by 3. Okay, so we do this by distributing this cube here to the 5, that's why it's 125 over here, and then distributing it to the x variable. Okay, so remember your power law of exponents. Okay, raising an exponent on the same variable with another exponent will be having it multiplied. Okay, so 7 to the, or rather x to the 7th power to the 3rd power, meaning we're going to multiply 7 times 3, that's why we'll have 21 over here. Okay, now we simplify our equation and get rid of the radical. That's very good right now. It's now time to get the value of k. We have only one k here. And reminding you that k is located on the exponent part of our equation. So in order to get the value of k, we need the help of a very important property of exponential equations. That is, we can equate our exponents, that is putting the equal sign directly in between them. And we can do that if our bases are the same. Okay, so remember bases as the one we are exponentiating. So this is a base for this left hand side, this is the base for our left hand side. We can do that, I mean we can equate the exponents if our bases are the same. And clearly here, well, 125x is equal to 125x, so our bases are the same. So we can use the property, we can use the property by equating our exponent here to x plus 1 and 21. That will give us this is our exponent on the left hand side, 2x plus 1 equals 21. So given this equation, the maths here will be very easy now. Transpose the 1 on the other side. Okay, of course, the sign of the 1 will be flipped because of the transposition. Perform the operation. Okay, 21 minus 1 is 20. And then we need to isolate k. We isolate it by dividing its coefficient. That is 2. So 2 over 2 will cancel it up. That will give us k left, which will be left. And 20 divided by 2 is clearly 10. So here it is. The value of k is equal to 10. Okay, and that's it. Well, you can check this by plugging in 10 to our k in our original equation to see if the equation will be equal, and which I'm sure it will be equal. Okay, so that's the solution for our problem number 2. Again, for more math problems, like and follow our Facebook page. I will provide a link on the description below, or you can see it here. So it's facebook.com/USLS math. And don't forget to subscribe to our YouTube channel, okay, to be updated of our latest content. Okay, thank you.